For our next example, we have a little bit of a different setup here. In the previous example, we had an x value or an x variable that was being squared directly. You can see in this particular example that we don't have the x value being squared directly. We actually have an entire binomial, x plus 5, that's being squared. So when we see something like this, really what we're looking to do is we're looking to isolate that term. So we want to, in this case, example number 2, peel away the 1/3, if you will, to get the x plus 5 squared by itself. Now, if you look at the solution to this, what we're really going to be doing is multiplying each side by a common denominator, or the reciprocal in this case, so that we can eliminate that 1/3. Now, once we get x plus 5 squared on its own, then at that point we can actually take the square root of both sides. Now, a couple things here. Once we get x plus 5 equals plus or minus square root of 21, and we need to get x by itself, when we subtract 5 from both sides, it's important that you put that in front of the plus or minus instead of behind it. This will help us out later as we have to format our answers in different ways. Now, if you notice in this particular problem, the square root of 21 cannot be reduced. However, you may get in a later problem a radical that's a perfect square, and at that point you would want to break up the two parts, the plus and the minus, so that you could combine the like terms that were given. So let's go ahead and take a look at a couple examples here. Sample problem 2 has a part A and B, so go ahead and stop the video at this time and try to work those, and then come back and look at the solutions. Okay, if we look at the first problem, the first thing we're going to want to do is we're going to multiply both sides by 2. 2 times 1/2 is going to cancel out, and that's going to leave us x minus 2 squared equals to 16. So now I've got the squared term isolated, and so from here I just want to go ahead and take the square root of both sides, and that leaves me x minus 2 equals to plus or minus 4. Now, this is important, it'll help you see what's going on a little bit better. Whenever you take this and you add 2 to both sides, we're going to want to put it in front of that. So we're going to have x equals to 2 plus or minus 4. Now we're in a situation here where the 2 and the 4 are like terms, so they can be combined, and we would want to break that plus or minus symbol up, and so it can equal either one of these. And so now we can actually have two values of x in this particular case. Alright, let's take a look at the next one. Again, we're going to eliminate this fraction immediately by multiplying times the reciprocal, which is going to give us x plus 7 squared equals to 24. Then we'll take the square root of both sides, giving me x plus 7 equals to plus or minus the square root of 24. Now notice this time the square root of 24 is not a perfect square. So when I subtract 7 from both sides, I cannot directly combine those terms because they're not like terms. So here we would simply just need to reduce the radical or simplify the square root of 24. And that's going to simplify times 2 times the square root of 6. And this is going to be our final answer because it has both the plus and the minus values in here, which gives us two solutions to this particular problem. Okay, and then on our next lesson we'll look at one more type of problem that you could see using square roots.